Rusty Russell is an Australian programmer known for his work on Linux networking, and he now works on blockchain technology at Blockstream. Rusty, welcome to Software Engineering Daily.
Thank you, Jeff. It's great to be on here.
What is a sidechain?
So the idea of a sidechain is basically that you can have an alternate parallel system with the Bitcoin chain in a way, and this is the really exciting bit, that you can move coins onto the sidechain and move them back off the sidechain with minimal trust. You don't have to have some broker who's brokering between them. You can have a similar kind of proof of work system that goes from one to the other. So this is, this opens up a whole world of different things that you can do that you might not be able to or might not want to do on the main Bitcoin blockchain.
And what are some of those things that you would be able to do?
Okay, so I can give you a concrete example. We released like an alpha sidechain that has some, it has a few technical improvements that are kind of cool, but would be difficult to do in a backwards compatible fashion. But one of the probably the most exciting ones for me was confidential transactions. You can actually use cryptography, zero knowledge proof, hand wave. I'm not going to go into details to actually prove that a transaction balances, that the amount it pays out is the amount that comes in, without revealing any of the amounts themselves. That's obviously something that you can't do in Bitcoin at the moment because it's a public ledger, the amounts are obvious. Whereas in alpha, you can actually have these confidential transactions where the amounts are obscured, and that's incredibly exciting. And that was probably for me the most mind-blowing feature of the alpha sidechain.
I had a conversation with Vint Cerf recently, and he said that he was concerned about anonymous transactions. Are there any? I assume that your net benefit in your mind outweighs the net concern. But do you have any concerns with the introduction of anonymous transactions?
So Bitcoin was always meant to be anonymous. It turns out that it's not. It's pseudonymous. It's not completely untraceable when you've got a public ledger. This would bring it closer. Now, what's interesting is that the people who are most interested in the sort of the ability not to disclose the amounts they're transferring tend to be businesses. People who don't want to leak that kind of information about their relationships to their competitors. So it's really interesting. The interest from that has been a lot from businesses who are looking at doing things on the blockchain who don't want everyone to know that they're how much they're paying out in payroll or things like that.
Okay, interesting. How do you define a blockchain?
That is a very good question. If we look at the canonical blockchain, which is Bitcoin's blockchain, it's a ledger that is incredibly difficult to extend, thus incredibly difficult to fake. That's probably the simplest definition of blockchain that there is.
And so then, speaking more specifically, what are the variables that are typical to a blockchain data structure?
So usually you've got some kind of proof of work, so it has to be difficult to generate. So you have a nonce or something that you can play with, and you basically keep trying things until you get lucky and you get a valid block. It has to contain transactions. So transactions are things people send out on the network, and they get included into blocks. So basically a block is a chunk of transactions that the miner has seen, and it has to refer to a previous block. So you can't just produce them all in advance. So as long as you've got a back reference, you've got something that's cryptographically difficult to generate, and you've got some transactions in there, which are simple cryptographic transfers of tokens. That's basically the ingredients that you need for a blockchain.
What is your definition of a nonce?
Nonce. Okay, so a nonce is basically something that it's an arbitrary number that serves no real purpose. You can just keep changing it. So, for example, if you're mining, right, you've got to get a block whose cryptographic hash is below some value, right? Some really, really unlikely low value. So what you do is you start the nonce 0, you do the hash, nope, it doesn't work. Increment it, turn it to 1, try again, no, it doesn't work. And you just basically keep changing the nonce until you get, hey, whoa, this one works. You send it out. And there's no known way to do it faster than that. The only way to do it is just to try a whole heap of different options. And that's the fundament of mining. And that's the basis why it's so hard.
Could you describe the analogy between a blockchain and a Merkle tree?
Okay, so a Merkle tree is a fantastic data structure, and I have a whole talk where I went really, in depth on my love of Merkle trees. So a Merkle tree is a really cool data structure where you can compress a whole heap of information. So you've got, I don't know, say 100,000 transactions, right? Now, what you want in the block, you don't want to have to hash 100,000 transactions every time to go, oh, okay, I changed the knots. Now I, go through, I'll hash 100,000 transactions. Oh, no, it didn't work. Okay, that would be a great deal of work. So you basically build this tree of all the transactions down to a single root. And the way you do that cryptographically is you hash each node, and then you take those two hashes in pairs, and you hash that pair of nodes. And you work your way up all through all the levels until you get down to the top of the tree. And that basically summarizes the contents. Now, the way the cryptographic hashes work is there's no way to reverse them. So what it turns out is that if I give you that top level, and I say, hey, the hash is ABC, XYZ, etc., I can prove to you that this transaction I give you is actually in that tree by giving you log n, say log 100,000 in this case, nodes that would go alongside that to combine together, and I can prove. So really compactly, I can prove what's in that tree, which is really cool. And that is, in fact, the way that blocks in Bitcoin contain transactions. They're actually in one of those Merkle trees. But I wasn't going to go into that until you brought it up.
Okay. Yeah, thank you for that crisp explanation. That's related specifically to blockchain, but it's material that I wanted to cover in more specificity this week, and I haven't gotten to cover in previous episodes. So to get back to sidechain discussions, what is the minimum blockchain spec that is compatible with the sidechain technology that Blockstream is developing?
So that is a really good question. The whole innovation of sidechains is not just, hey, you can produce another blockchain. You could always do that, right? You can go out and make as many as you want. The innovation was being able to prove to Bitcoin that these coins have been sent back from your sidechain. Right. Now that means that you use this similar, the Merkle style proofs, which you've seen, discussed before, so they're fairly compact. You can prove, hey, this transaction actually happened in here. You've also got to be able to prove that it happened sometime in the past. So you can't have just created a block and put the transaction and go, hey, see, look, they sent the money back to Bitcoin. Here, give me some more Bitcoin back, because miners can race. There could be a dishonest miner. You've got to make sure that it's had enough work buried underneath it to be really, really confident that that really is the agreed truth in the sidechain. So what this effectively means is you have an operation that Bitcoin would be extended to have called something like ops sidechain verify that would have enough of the sidechain in a summary in it that it could prove that this transaction that returned stuff onto the Bitcoin blockchain had actually happened in the sidechain. So what this actually means is that the sidechain has to look a lot like the Bitcoin blockchain, because Bitcoin has to be able to understand it. So it needs to look, it has to have similar kind of headers. It has to have a Merkle tree. It has to have transactions, or at least the transactions that are returning to the Bitcoin blockchain have to look a lot like Bitcoin transactions so Bitcoin can understand them. Now, as long as you meet that spec, you can do anything else you want.
So when you were designing, or when Blockstream was designing that spec, I know you're not directly involved with sidechain technology at the company, but do you know if there was any discussion around, maybe the Bitcoin spec is not, it has flaws. Maybe we should create a new, base blockchain spec to extend from. Was there any discussion like that?
No. So, there's always, as an engineer, you're always, bitching about your technology, right? So, there are certainly warts in the Bitcoin protocol that could be improved, and that applies to everything, IPv4, IPv6, you name it. You can think of a way to improve it. So the exciting thing with sidechains was that we don't have to do that. Here's our chance to have our cake and eat it too, right? So you set up your sidechain that has this basically, at a high level, it kind of looks like enough like Bitcoin that Bitcoin can understand it. But then you can do all these cool, crazy things almost whatever you want. If you want to go really clean and change some features, you could do that, and still have all the benefits of the fact that you're using real Bitcoins, that you're actually attached to that whole Bitcoin blockchain, although you're one level removed. And some of the security properties are slightly weaker than doing the full Bitcoin thing. The good thing is the only people, if the security of the sidechain falls apart because it was badly designed, the only people who would lose their money were the people who transferred their money into the sidechain. That would be the worst case, that the money would somehow leak back onto the Bitcoin network without having supposed to have left the sidechain. So it's perfect for damage containment like that, but it also allows you to experiment and do some pretty crazy things.
Yeah, I did a week of shows on JavaScript, and JavaScript seemed to be a story of where a minimum viable technology just showed to be good enough, and then people just built abstractions on top of it. And that sounds similar to the philosophy behind sidechains. One of the complaints that you sometimes hear about Bitcoin, and obviously this is a feature as well as a bug, but the Bitcoin scripting language is not Turing complete. With sidechain functionality, is there an element of Turing completeness that's added?
It's certainly something you could do. It's something we haven't done. We've basically stuck pretty close to the standard Bitcoin script for the moment, but you could certainly see sidechains doing something much more ambitious along those lines. There's no reason why not.
What are the hazards of that Turing completeness?
Well, for start, obviously, if you can create a script that is not easy to evaluate, that could take miners a huge amount of time to evaluate, you could basically grind the network to a halt when you try to spend some money. So the obvious things are denial of service, those kind of things. The advantage of the Bitcoin scripting system is it's pretty easy. There's no loops, right? So it's pretty easy to look at it and go, we can guesstimate how long this is going to take to evaluate. There are actually some nasty corner cases, but pretty much it's straightforward. Now, when you start introducing more complex constructs in your language, we know that at a certain point you can't prove that it will actually ever terminate. So there are certainly some things to look out for if you want to get more ambitious with your scripting, but that's not to say that it's impossible. And sidechains would be a fantastic way to experiment because hey, if nobody puts their money on your crazy sidechain, you can only lose your own money doing it. So good luck with that.
How do sidechains help avoid centralization?
That's a really interesting question. I don't know that they really do. They avoid a problem we already have, which is that you want to be incredibly conservative with what you do with Bitcoin. There's a lot of money riding on it. It's a consensus system, so everyone has to kind of upgrade pretty much in sync. You've got to be incredibly conservative with your decisions there. If you have something you want to do that's more ambitious, well, now you've got kind of a problem, right? You either have to convince, the vast majority of people that it's incredibly important, or you have to make it so low risk that you can't, that it really is a no-brainer to add. So generally, we've seen the Bitcoin developers extremely conservative with what they add to Bitcoin. This, as I said before, lets you have your cake and eat it too. So it does allow that potential flexibility and allows us to explore a whole heap of options. But directly, I don't know that it does a huge amount for centralization either way. You could create a sidechain that had worse centralization problems than Bitcoin did. I mean, you could do whatever you want. On the other hand, it may allow you to experiment with things that would let us, lock in more decentralization properties that Bitcoin has today.
Is a Git branch a useful analogy to a sidechain?
On a high level, yeah, it is. I mean, it has, obviously, you've got a similar kind of basis, and you go and you do something else, and ideally you merge things back in. On that level, yeah, you could think of it as a Git branch. On the other hand, you could also think of it as a river forking, and which may rejoin at some point. So, from any technical point of view, I don't know that the Git analogy is really going to get you very far.
Right. So you mentioned the necessity of synchronizing. Everybody has to synchronize. They have to come to a consensus on an update to the Bitcoin software. Could you explain how that occurs? That's a topic that I haven't discussed this week.
Okay, so currently, with one minor and almost unnoticeable exception, in the modern Bitcoin era, so since 0.3 or whatever, you can fire up that client and it will successfully parse the blockchain and every transaction in it that has ever occurred since the Genesis block. There have been no what we'd call hard forks that basically force an upgrade on everyone. Now, that is a two-edged sword. While it will say, yes, all these transactions are correct, there have been additional constraints placed on transactions called Softforks, which means everything, which basically means you can add restrictions, but you can't remove them. So an old client looking through will say, well, all these are valid, right? A new client will maybe do extra checks and say, yeah, okay, yep, these are definitely valid, which means that if you've got a really old client and it sees a transaction, it might think it's valid, but it will never get in a block because, in fact, the rules have been tightened. So the basic rule is that the rules can get tightened, but they can't get loosened. And this is the rule of a soft fork. It has allowed you to basically do rolling updates to the Bitcoin protocol without breaking everyone and forcing this flag day change. The downside of this is that you may not know that you're not doing full verification anymore. You may not know that there's a new rule that's come in, and suddenly you thought you were checking everything. Somebody sends you something that looks valid for you, but the rest of the network will go no, and it will never appear in a block. This is why in the last 4 years, the updates have always been flagged by a voting kind of mechanism where we've seen the version number bump. When the version number bumps and you don't know why at this point, your client can go, hold on, I didn't expect that to happen. We've reached like a 95% consensus. I assume that something has happened on the network that I don't know about. You should probably upgrade me at this point because I'm running in like a non-full validating mode now. There's been some activity on this discussion around this recently. In fact, there's a Bitcoin proposal to really formalize that process, but it's pretty certain at this point. That's worked quite well for the last two soft forks that we've had. That the version number will change. So there will be a non-silent soft fork. You'll be able to detect it, even if you don't know what it is. And I think that's important too. Does that answer your question?
Yes. So what are the advantages to doing development on a side chain rather than the main chain?
Oh, exactly that problem. I mean, you can change things that you couldn't change in Bitcoin. Now, the constraint of having to soft fork means that you can't change the meaning of something that's there already. You can't get rid of something that's already there. Well, you can get rid of something. You can't, go, hey, we're going to completely change the way this works, for example. I hate the way, our Merkle tree structure, for example, it has a stupid thing when it's got an odd number of transactions. We should fix that. All those kind of warts, you can kind of go nuts with a lot of them and change things. So that's kind of nice. And of course the structure that we've seen in the sidechain alpha that Blockstream released does things like confidential transactions where you don't even see an explicit value. Maybe you could retro that in some kind of cool way into Bitcoin, but it'd be a lot more work, and you'd have to be very, very careful that things still look completely valid to old clients. So, if you're trying to do crazy experimentation, this is a cool way to do it without having to worry so much about backwards compatibility.
Could you describe how a sidechain allows for transfer between asset types?
Okay, so asset types are something that's kind of really, really interesting. There's basically only one asset type in Bitcoin. There's Bitcoins. But there's nothing fundamental about a blockchain that says you can't have different tagged asset types. And that's really all it is. If you had a tag on each value, as long as, you got as many sheep in as you put sheep out, that's fine. You could accept that. So from a protocol level, it's really easy to add, hey, just have a tag and then, make sure the arithmetic works and that, as many things go in as go out, and you've got conservation. Now, there's a little bit more to it than that. And you can do some really cool things. And I'm hoping that some of those things will actually happen in the next release, because not everything we wanted to do with assets came out in alpha. So in beta, there may be some more, some more impressive use of asset types in that. But fundamentally, there's no reason why you can't have multiple asset types on the same blockchain.
So you mentioned the term tagged. Is that the same as color coins?
So very similar. Color coins basically layer on top of Bitcoin. where you assign, you go, hey, well, this coin here actually has an extra meaning. It's not just, a tenth of a cent or whatever. Whoever holds that in the ledger also owns my car or whatever it is that you've colored it with. So this idea that you can put an abstraction layer on top is kind of something different. It's basically retroing it into the existing Bitcoin system, right? So it's kind of like, hey, you've got this $1 note, and actually, it's signed by some celebrity, and that says that you can get into the party for free, right? So yeah, it's cash on one level, but on another level, it has a higher level meaning. So colored coins are kind of the same idea, that you can tag something and you can go, yeah, okay, this actually means something else as well, that the underlying system has no idea about. You can still use it as a dollar, but just anyone who knows it, they can look at it and go, hey, yeah, cool, come in, you're not a problem. So that's the idea behind colored coins. When we talk about tags for assets, it's actually something embedded into the protocol, and the kind of thing that's unlikely to happen in the Bitcoin main chain, which is why sidechains would be so good for it.
So when we talk about like the use case of like a parent wanting to give allowance to his child and have that allowance only be allocated to like textbooks and vegetables, would that be like a use case for a color coin or a tagged type of currency?
You could do that in Bitcoin today. So what you would probably want to do is do a 2 of 2 signature kind of thing, where you can sign and the kid can sign. So they go, hey, I want to spend on this. And you go, yeah, you're going to need my signature as well. But that way you can't use it as well. And maybe some proportion they can spend free, if they want to spend money on, on junk food or whatever. That's cool. They can have, some ridiculously small amount that they can spend on that. But the rest of it is going to have to be co-signed by 2 people. It's interesting when you try to come up with analogies like this, because you start thinking about, well, how would the protocol define what is allowed and what is not allowed? And it very quickly, you turn out you're actually better off doing some kind of multi-sig thing, because you're going to need a human in there to go, no, that's not a vegetable, so you can't buy that, or whatever.
Interesting. What does sidechain technology mean for the altcoins?
That's a really good question. So an altcoin is basically, Bitcoin's open source. Take it, change the name Bitcoin to Rusty Coin everywhere, said through the source. Classically, though, when you do that, don't change the copyright messages, because that would be wrong. A lot of altcoins have made that mistake. So other than the copyright messages, because it's still copyright the Bitcoin core team, change it all to Rusty Coin and release it and go, hey, everybody, you could be rich by owning Rusty Coins. Now, funnily enough, that doesn't work very well, although it doesn't stop people from trying. And frequently they claim some great new feature. And very much altcoins have been tainted with this idea of, kind of pump and dump schemes and things like that. There are a handful of altcoins who've tried to actually do interesting technological things, but generally they've been drowned out in this wave of make money fast kind of altcoins. So, you talk to somebody who's into Bitcoin or like about altcoins, they tend to be a little bit, gun shy about the term. So, one advantage of sidechains is you can kind of go, no, this really is Bitcoins. You really can lose real money on this, rather than this hey, we made up something new that's just a clone. So that's the fundamental difference between sidechains and altcoins. Now,
wait, I'm sorry. So is that like a gold standard type of thing?
In a way, yeah, that's right. I mean, in a sidechain, you transfer real Bitcoins on. If you screw up, you lose real Bitcoins. If on an altcoin, hey, you've just made a new currency, you screw up, you lose your useless currency. It's probably not a big deal.
Okay, that's fascinating. That's a fundamental thing that I did not know before this conversation. So you mentioned that copyright thing. What happens in those instances when somebody forgets to include the copyright?
I don't know. It's just something that I know has happened in the past. People just said the whole source code. It's like, well, actually, you probably need to leave that Bitcoin copyright in there. Just a tip for those of you, go out there, budding altcoin authors out there.
Do you see a future where everybody is going to have their own currency?
No. Currencies are useful because they're used for exchange. So having your own currency is a complete vanity exercise for the vast majority of us. I mean, nobody would buy Rusty Coins. My parents might buy $1 worth. There's really, there's no point. a currency as a means of exchange is something that we both value. So it doesn't really make sense for everybody to start up their own currencies.
So there's no incentive for Apple to go and say, like, we want to make Apple Coin. This is the only way you can buy Apple products. It's, we're issuing a limited commodity. We've got unlimited iPads, but we have a limited number of Apple coins. I mean, maybe this is like an absurd example, but I just bring it up to, in case you've had any interesting conversations or any thoughts about this, why this would be conceivable.
Well, everything is conceivable since you just stated it, right? We've seen loyalty schemes and things like this. Could you use some kind of coinage thing as a loyalty scheme? Perhaps, but it would basically be the same thing you've already got, right? I mean, it's centralized. They control it. Why would they bother with all this distributed technology? Why don't they just go, hey, here's some tokens. We're going to call them Apple Coin. That probably makes more sense than trying to do a whole distributed, decentralized currency if they're going to control the whole thing anyway.
Speaking more broadly, what are the biggest difficulties with developing generalized sidechain technology?
What's the biggest difficulty? That's a really open question. That's sort of like, what's the most difficult thing about developing? Thinking first and typing second and never the other way around is probably the hardest thing. Because
so I should say things that are unique to Bitcoin or sidechain development rather than conventional development. Not like organizing the Kanban board or something. Something super general.
Okay, so we've cut that back a bit. Probably the most difficult thing, because it really depends on what you're trying to do. You come up with hey, we need a cool sidechain that does, this great thing of confidential transactions. The difficult one in that is probably, getting the crypto right, getting it reviewed, making sure that it's sane, that it's not broken. The parts where you have to actually, modify Bitcoin to produce this sidechain and things like that, generally relatively straightforward. But again, it's a very open question because you look at the different features that we put in alpha and you kind of go, well, each one kind of had different pain points, I guess. Some of them were really easy. I mean, they were like, hey, we just need to uncomment this line and change this here. And hey, we've got our new feature. Others were much more involved, and probably confidential transactions was the most intense of those.
Intense in what way?
Just, when you're really doing some I won't say novel crypto because it's all fairly well established, but whenever you're touching crypto stuff, you always got to really worry that you're going to either screw up your implementation or you'll think it's a great idea and it turns out that it's deeply flawed or whatever. Gregory Maxwell led that and got a non-trivial amount of external review on the ideas and the structure before it went out, so we're pretty happy with it. But when you're doing things in the crypto space, you always have to be very careful about what you're doing.
What is a two-way peg?
Right. So a two-way peg is, okay, well, let's step back a bit. So the idea and the thing I said before is, hey, you can basically move coins without any trust. So you can, it's pretty easy in your sidechain because you can do just about anything you want to prove, hey, look over here, Bitcoin sent these coins to us. Now we can use them. And then you have an update to Bitcoin that allows it to understand sidechains, and it can see that the coins are coming back, and it lets you spend them. Okay, so that's kind of the end game. That's what you want eventually. But that requires a non-trivial modification to Bitcoin to extend for this opt sidechain verify operation so that it can do this parsing and so it can understand the sidechain. That's a modification to Bitcoin that would be required for the full thing to work. So what do you do in the meantime, right? As I said before, Bitcoin development, very conservative. You don't want to put something in just because it might be useful. You really want to put something in that's proven itself as something that you really want. So in the meantime, you do a two-way peg. So you actually have these functionaries who you send the Bitcoins to, and they all agree that the Bitcoins have been sent, and they inject them through onto the other side, into the sidechain, and vice versa. So it is not a trustless system. You have, some number of intermediaries sitting there that are shuffling the Bitcoins to and from the sidechain. It's an intermediary step, so you can make sure that everything works, that you can do interesting stuff, and then you can point at that if everything's great and go, hey, this is a reason that we should put this into Bitcoin.
I'd like to transition to a conversation about Lightning networks. And to go in that direction, and Lightning networks are what you work on at Blockstream. Why is it hard to scale Bitcoin's blockchain?
Okay, so that's kind of addressing the Lightning Network backward, but we can start here.
Well, where would be a better question to start with?
Okay, so we talked about what Bitcoin is, right? This blockchain idea that there's this ledger that's really hard to update, and everyone knows what the ledger is, and they agree, hey, that means that you own the coins, right? So when people hear about Bitcoin, the thing that's in their head is, hey, cool, this is like kind of instant transactions, and I can send you 3 cents and you'll get it instantly with no fees. Well, it turns out that's not quite the case, because the transactions have to go into the ledger. The ledger's only updated on average every 10 minutes, but it's not a standard distribution, so the median's about 7, but there's a 1% chance you'll be waiting for like 42 minutes until things are in the ledger. And until that happens, I could double spend it, so you can't be really sure you've got the funds, so it's not quite instant. And also there's going to be a slight fee involved, because somebody's got to pay the miners, at least in the long run. So, and we don't want people flooding crap on the network, so there's a small fee. So, sending 3 cents may not be the greatest thing you can do. Lightning kind of brings back what people first think of when they hear about the Bitcoin network. It's a caching layer for the Bitcoin network.
Oh, okay.
So when you think about it that way, you kind of go, okay. Now, when we looked at scalability, coming back to your question about scalability, there was always this idea that eventually Bitcoin network will be huge, and what are we going to do? Is it going to be as the subsidy that miners get degrades? How is this going to work? How is this thing going to scale? There was this idea that people suggested for a long time that we'd do a whole heap of stuff off-chain, and then the big amounts would be transferred on-chain. It would kind of become more of a settlement network than a kind of thing you'd pay for your coffee with. So this was an idea that's been out there for a long time as kind of an answer to how we would scale if we hit limitations in scaling. What we didn't realize until February of this year, when the Lightning paper came out, is how very close we were to already having the ability to do this with Bitcoin today. And that was, for me, the incredibly exciting thing about reading this paper, is that they said, with a couple of non-controversial enhancements that have already been discussed effectively for the Bitcoin network, you can produce this system where you send each other these combinations of transactions. They do look kind of complicated, but that if the other side tries to screw you, you can immediately drop it on the blockchain like normal and get your money back. So it's effectively, that's where the caching layer idea comes in. If we're all cooperative and it's all good, we actually never need to put anything on the Bitcoin blockchain other than an initial what I call an anchor transaction. So basically we put funds in, but then we can spray funds to each other back and forth, and as long as we're both cooperative and responsive, we never need to put that money back and drop those transactions back on the blockchain. So that's one part of it, this idea that we can do these updates between ourselves, and knowing that the blockchain is there if we need it, and that we structured these things so that this can always work at any point. It's all valid, and we can basically go, okay, you've stopped responding or you've stopped obeying the rules. I'm going to broadcast this out to the Bitcoin network, and it will go through like normal. We'll have to wait, 10 minutes or whatever, but it will happen. This gives us a couple of things. It gives us instant payments for a start. It gives us, except when the case goes wrong, in which case it's not much worse than Bitcoin was to start with. It potentially drops costs, because now it's just the two of us talking. We're not involving an entire network, broadcasting around the world, making sure everyone's in sync. So potentially the costs here are lower. The other thing that's really interesting is that you can turn this into a network of transaction. So instead of just you and me sending these coins to each other, which is maybe useful in some scenarios, but really isn't that useful if you're not the person I'm trying to spend money with, I can arrange it such that I will pay you if you get this money to somebody else, who gets this money to someone else, who gets this money to Walmart, right? And you can do this all in a trustless way. So you can effectively create a network of these things. So I don't need to immediately have this, this Lightning channel open to all these people. I can route through other people to get where I want to go. And presumably you'll insist on a tiny fee for your service of having things routed through you. But hey, no skin off your nose, so you might as well make it fairly cheap. And away we go. So this thing can develop. This is why the Lightning Network is called a network, because you can actually not only have this caching layer where you basically send transactions to each other, guaranteed that if something goes wrong, you can drop back to the Bitcoin blockchain, but also you can bounce these through to other people.
So you mentioned a set of non-controversial changes that needed to be made. What are those changes?
Okay, so the original paper wanted 4 changes, and since revising that work, I
by the way, these are changes to Bitcoin's protocol.
These are changes. That's right. These are soft fork changes to Bitcoin's protocol, and the original paper wanted a malleability fix. So there's a Bitcoin improvement proposal involving restricting malleability. Malleability is basically where you take a transaction that's valid and you can mutate parts of it such that it's still valid, but now it has a different transaction identifier. The transaction ID is basically the hash of the entire transaction. So that if you can change something in that and it's still valid, you end up with different transaction ID. Now this turns out to be a problem because when you say, I want to spend this transaction's output and put it over here, you refer to that by transaction ID. So if we're relying on building up a chain of these transactions off the blockchain, then if you can mess me up by changing one of the early ones, so as transaction ID changes, it breaks the chain of transactions we've built and everything goes straight to hell. So that's long been discussed. Everyone's known we should do it. It's just a matter of getting it done. So there's already a Bitcoin improvement proposal to do this. It's backed up in the queue, but it's definitely there. One of the other things that we really want is the ability for an output to say, you can only spend me on this date or this block number. We currently have an ability where you can create a transaction that can only be spent after a certain time, but we don't have the reverse, where an output could say, hey, you can only spend this money after a certain time. Again, there's an improvement proposal to do that. It introduces a new opcode from one of the existing no-ops called op check lock time verify. That's already a formal proposal. It's fairly, the scene is fairly useful, and it's something, again, that's in the improvement queue. Now, if we also have the ability to have a relative one of those, which is another proposal, which is in the queue, it turns out those 3 things by themselves allow us to do the Lightning Network. Originally, the paper required a 4th change, which was more controversial and more likely to logjam because it was less well developed and had a whole heap of cool things we could do, which is going to make it kind of harder to come to consensus on what we should do. But it turns out that we can actually drop that and still produce the Lightning Network.
Fascinating. So to listeners who may have lost track, to bring them back to the conversation, to have them understand this better, could you define the term micropayment channel?
So micropayment channels have been around for a number of years, and it's a really interesting idea. The idea is that we talked previously that you can have multiple signatures. So say you and I have to sign the transaction to spend it. So I put a transaction on the Bitcoin blockchain that says, hey, here's $5. As long as Jeff and I both sign, we can spend it, right? Now, before I put that out there, you and I have signed a transaction that says, yeah, all the $5 goes back to Rusty. We're good. Okay, so I can get my money back at any point because I've got your signature on that. So we wait for that funding transaction to go out into the blockchain and get, bedded down. So it's fairly deep in. We're pretty sure it's not going to get undone. All good. Now, I could drop that transaction that gives all the money back to me immediately. Or if I want to pay you 1 cent, I could send you a transaction that says, hey, actually, pay Jeff 1 cent and pay me $4.99. And with my signature on it, of course, you can sign it too. I want to pay you another cent. I just send you an updated one that says, hey, actually, give me 4.98, give him 2 cents. And I can keep sending those to you, right? Now, at some point, you can go, okay, we're done with this transaction, and you drop the last one that I sent to you onto the blockchain. So in this way, basically, we've been exchanging transactions, but we haven't bothered pushing each one out to the Bitcoin blockchain every time. Okay, so this is the basic idea behind a micropayment channel. Now, there are a few caveats with this that are involved. I mean, there are timeouts that have to happen in case one goes non-responsive. The basic idea is that, yeah, once we've got this single transaction in the Bitcoin blockchain, we can build on top of that and spend that in different ways between the two of us as long as we both agree, and we don't have to push every single transaction out. The downside of this is, of course, it only works between you and me, and we have to wait for the first transaction to be, deep enough that we're both happy that that's not going to be unspent. But once you've got that, it could work fairly well. One of the cases where this has been mooted as a solution is for things like, when you use an internet cafe or a Wi-Fi hotspot, where they really want to charge you about 0.1 cent per minute or something. You could use this kind of channel technology to do that payment efficiently.
And so I've heard the term micropayment channels do not require trust. Could you explain that phrase to me?
Okay.
Okay. It makes sense?
Yeah, it does make sense. Okay. So they don't require trust in the sense that I don't have to trust you, right? It's not like I'm giving you $5 and then at the end of the transaction going, hey, okay, so can you give me my $4.98 back, right? That would be a trust transaction, right? I could just give you, hey, transfer this money to you and then ask for the money back that I didn't spend. That would work, but it would require me to trust you, right? Because you go, no, and vanish. Similarly, you could trust me the other way. You could go, oh, no, at the end, hey, you owe me 2 cents. Can you pay it now? Hello, Rusty, are you there? Obviously, that's a trust transaction too. With this dual signature idea is that, neither side can really screw the other. So, for example, I've sent you, these multiple versions of this transaction. You're obviously going to spend the one that gives you the most money, right? So, the version that gives me $5 back, that's time delayed, so I can't spend that till tomorrow. So as long as you don't wait, till tomorrow, I can't get my money back. But you're going to spend the last version I sent you, which will basically pay you the most. So you don't have to trust me. I don't have to trust you.
So to continue our conversation about Lightning networks, what does it mean for transactions to be, I know you've touched on this already, but what does it mean for transactions to be sent off blockchain?
Okay, so you can always have transactions that you send out to the blockchain. That basically implies that it goes in that global ledger. Everyone using Bitcoin effectively has to have some knowledge of it. The miners have to get it. They have to race each other to put in a block, all that stuff, right? So this broadcast network, it has to go out to. There are obviously some scaling limitations to that, to doing that on any scale, because basically you're having to broadcast things to everyone. By having things off blockchain, it's basically just between the two of us. At some point, you may want to collect your money, and at that point, you may broadcast out to the blockchain. But they don't need to know every single detail of what we're doing. So, we can adjust the amount we're paying each other, all those things, without having to bother the rest of the world about it. So it's off-chain for the vast majority of the time, and at some point, maybe we may close up, and we'll settle on the main chain.
Are there any I don't know how much you've read about Ripple, but do you know if there are any philosophical similarities between the Lightning networks and Ripple? Because it seems like there's some sense of partial trust. You have these partially trusted networks, and you leverage that trust to have speedier parts of the network. Is that an accurate analogy?
It's a very interesting analogy, and something that people immediately think of. Ripple is this sort of like distributed IOU kind of system where you have to trust the next node. Lightning does not have trust. With Lightning, if you try to screw me, I just dump everything on the blockchain and I get paid like normal, right? It takes a little bit longer. The only thing I'm trusting you is that you're not going to mess me up, so I have to wait, right? So presumably you're earning fees and things like that. So there's a reason for you not to do that. But hey, if you do something wrong, the worst thing you can do is make me flush everything out to the blockchain. So that's the difference here.
Is there any analogy between the maybe this is like totally off base, but like how a transaction across a micropayment channel works and three-phase commit? Or is it totally off base?
It is kind of similar. No, I see where you're going with this. And to some extent, yes, it is, because there's this thing in transit, and at some point you actually commit to it for real. The difference is with three-phase commit. Well, yeah, three-phase commit is fairly accurate, but when you think about a transactional model, there's state that can be lost. With any kind of micropayment channel or the Lightning Network, you can never go backwards. I mean, you're basically committing to something at every point in time. Of course, it's always possible. There's huge disasters. If you can never reach the Bitcoin network again, you will never be able to get your money by definition. But you've probably got other problems at that point.
So, how do Lightning networks enable, and just to really drive home the point of them? Could you describe how a Lightning network helps enable an instant transaction like a cup of coffee?
Yeah. So cup of coffee is like the classical, example that everybody uses, right? Because, you look at the number of cups of coffee used around the world and you kind of go, here's the world's population. And, even if it just becomes coffee net, what kind of transaction volume are we doing just to buy our coffees? And, at some point you go, well, how much are you willing to pay for those $2 transactions? So on the Lightning Network, it's really, really easy. The model that Joseph, one of the authors of the paper, suggested to me is basically your phone connects to 5 random nodes on the Lightning Network, establishes the channel, so puts a little bit of Bitcoins into each of those channels, and then your coffee provider goes, hey, pay me here, and basically you figure out the route that you're going to have to send your money through to get to them, and you go, okay. I mean, you don't. Your app does, because okay, I will send that through here. There's a bit of crypto between each point, and it's a network, so there's a few hops, but it's pretty much the kind of latency you'd see on that transaction would be incredibly minimal. And at that point, they'd go, "Yep, I've got the money. That's good." Now, there's a potential that one of your hubs chooses that moment as you send the money through to fall over, vanish from the network, stop responding. At that point, you go, oh, crap. Now it's going to take 10 minutes for you to pay for my cup of coffee. I'll pay through something else, and I'll wait 10 minutes to get my money back then. So, there is a disaster scenario which involves, a little bit of downtime. But we look at real networks like credit card networks. When they fail, you've got downtime, and you have no guarantees on how long it will take to resolve. At least this case, you can go, okay, crap, it's going to take this long for me to fix this. So in the general case, it would be as trivial as people imagine Bitcoin payments should be today.
Right, and just to emphasize how far the importance of Lightning networks reaches, could you explain how Lightning networks enable exchange arbitrage, which is sort of on the complete opposite end of the use case spectrum?
So I find this case kind of less interesting, actually, because what I'm really interested in is a whole level of microtransactions, not the coffee level, but the really tiny level.
Would you rather go through the micropayments example?
Yes, I would much rather do that.
Let's discuss micropayments. Okay.
The world has never had a micropayment system. We have never had a method of sending 1 cent around the world. We just haven't, right? When people talk about micropayments, they go, well, a micropayment is under $10. Like, no, that's not a micropayment. A micropayment is something so small you really can't measure, and it has a whole heap of different properties. Now, we have no idea what people would use these for because we haven't had them before, and that's exciting to me. I think potentially if we get Lightning right and it becomes an avenue for people to send subcents, it could change things in ways that I can't even begin to imagine because we just haven't had it. When people were asked, when they were doing market research for television, and people said, well, I don't have time to watch the radio, and they thought, hey, it's going to flop because nobody's ever going to use this. That's the kind of problem you've got with microtransactions. So, I'm hoping to build it And at some point, people will go, wow, this is, they will come up with uses I would never have thought of. So I think that's exciting. People look at go, hey, is this going to basically take some of the pressure off the Bitcoin network? And it's like, no. It's going to open a whole new area of stuff that we've never even seen before. And it'll almost be the reverse, right? Because this could be the killer app for Bitcoin.
Right, so just to specify, like, this is the kind of use case that really got me interested in this topic in the first place. It was like, you hear about Bitcoin at the beginning, and it's like, okay, it's this PayPal thing, and it's like, obviously it's missing the point. And then, people talk more and more about it, and it's like, no, so it lets you send a penny to somebody in Sri Lanka for 0 cost. And it's like, what? Okay, so you can do that? But what you're saying is that functionality actually it's not been implemented yet, and you're the guy that's working on it.
So yeah, I mean,
or you're exactly a guy that's working on it.
I'm one of the guys working on it. So we've got this is the vision when people describe Bitcoin. You go, hey, this is really cool, and then you just go, actually, there are these kind of caveats. Hey, it's pretty good that you can send money to Sri Lanka in like 10 minutes. That is actually pretty cool, but it's not quite instant, and you can send a cent at the moment, but because it'll be a low priority transaction because you're not paying any fees. So there are these caveats. This promises to be the real deal. Now, you've got to understand, right? Here I am coding it. There's a few other people who are coding things in parallel, which is fantastic. We've got this great excitement around this, but nobody's got a working, complete implementation yet, let alone the important part, which is the protocol so they can all interoperate and all those things, right? This is a long road. Plus, we have these requirements on the Bitcoin network. We need non-controversial changes that are already in the pipeline, but they have to actually happen. So, people get incredibly excited about this. You kind of have to step them back a bit and go, hey, software doesn't actually exist yet, requires changes to the Bitcoin network, requires a massive amount of infrastructure. You've got to have your Bitcoin wallet. It's got to understand the Lightning Network. All this stuff is going to take time. Now, I'm incredibly excited about it, but, that doesn't mean that people should send me emails tomorrow. Go, cool. I want to I want to make a Lightning payment to you. It's like, hold on. There are all these things that have to happen first.
Yeah, that's funny. So now that we've motivated this complexity even more, how does transaction revoking work?
Oh, this is exciting. I love this bit. So generally, you can't revoke a transaction on the Bitcoin network. Right? You can set a transaction and say this cannot be spent until this date, right? Which is kind of cool. But you can't say you can't spend this after this date or anything like that. You can't take something away. You can double spend it, right? So you can create a transaction that can't be spent. Meanwhile, you spend the funds somewhere else. Obviously, that transaction is now useless. But you just can't inherently unspend money on the Bitcoin. The real innovation of the Lightning Network paper was creating a mechanism to do this, to revoke a transaction. And the way it's done is kind of clever. I'll describe the way it was done in the original paper because it was kind of mind-blowing. We've refined it a bit since then. But the basic idea is that we create a transaction, it pays a certain amount of money to you, it pays a certain amount of money to me, but the stuff going to me is delayed. So I can put this transaction out. You can get your money immediately. Away you go. It's going to take, say, a day for me to get my funds back. Okay. But there's kind of an escape clause. To revoke this transaction, I give you my secret key. Right? And at this point, you're not subject to the delay. So if I publish this transaction, you grab your funds like normal, and then while I'm waiting a day for mine, you use my secret key and the key that you've already got to steal the other ones as well. And that's the basic idea of transaction revocation. We create this thing so that you can spend it, but the other person has a window where if you've given them the revocation key and saying, hey, I promise I will not spend this, they can steal all the money. And that's how we do transaction revocation. So with that system in place, then inside the channel, we can update things and we can revoke the old ones and go, I'm never going to use that. Knowing the penalty is if I ever use it, you just take all the money, and vice versa. These things are symmetrical. So we're both agreeing to revoke the old ones. And that was the really clever thing. It allows you to basically undo things.
What do you see in the future of blockchain technology?
That's a really interesting question, and not for the reason you think. It's really interesting because when we talk about blockchain technology, this has become like a key word at the moment. You need someone to power your blockchain. You need miners. You need incentive for them to be decentralized. You need all this infrastructure. And Bitcoin's the way we pay for that. So when people go, hey, we should just do that, but without the Bitcoin stuff, they're kind of missing the point that that's what's powering the whole system. It's hard to convince people to basically fire up these huge server farms of stuff to solve this problem so they all compete, so we have a decentralized system without paying them with something. So separating the two, blockchain technology and Bitcoin, is more difficult than you might think. So what we have in the future, it's really hard to say. Will we have some major breakthrough that goes, actually, we don't need proof of work anymore? Hey, there's this cool new way of doing it. Maybe, that'd be kind of cool in some ways, but we've been banging our heads against this problem for a long time, and we finally came out with proof of work. So it's not clear there's anything on the horizon that's going to supplant it. So when we look into the future and we go, what's going to happen? I don't know. If I knew, I guess I'd be rich by now. There are a lot of people going to make a lot of huge claims about what could happen. And I think some of those are quite plausible. We could see some really fantastic innovations. I like the idea of a browser plugin that basically, by default, will just send a tiny, tiny Lightning Network payment to every page I visit. Right? 0.1 cents, something that I don't really care about the amount I'm spending. Yeah, sure. I can hit a button to say, no, never send to this page. But that kind of thing could provide payment for content creators and things like that. We could have this radical new future where that becomes the norm. I don't know.
So I think what you're saying is that to ask about the future of blockchain technology kind of misses the point, because it's the real question is what are the future implications of present Bitcoin technology that hasn't yet gotten fully implemented?
Oh, absolutely. And that's an incredibly important point, that we're really using Bitcoin in baby talk mode at the moment, right? People are using it to go, oh, take money from here and send it over here. We've got this whole scripting language, and it can do all these really, really cool stuff, and we can have time lock stuff and multi-sig and all this stuff. And it's basically, we're using it at sort of, grade 1 level, right? So we haven't even really explored the possibilities of what we've got in front of us. And that's just the nature, however fast technology may move, to get these things widespread just takes time. So we haven't even explored the full extent of the stuff we've got. So, it's hard. I would have predicted that by now we'd all be doing this really cool things and flying cars and all that stuff, not happening yet. So, it's really hard to look into the future and say, here's the stuff. You talk to Bitcoin people, they talk about all these cool things we could do. And there are some great cool things we could do. But trying to figure out from the weeds which one of those things we actually will end up doing, much harder.
All right, I love your pragmatism. Speaking of pragmatism, is there any place for closed source code in the blockchain community?
So we didn't harp on this because it's kind of assumed, but of course all the stuff that Blockstream does is open source. All the stuff that all the Bitcoin stuff, it's MIT licensed. That's all fairly straightforward. All the code that I produce, my background is Linux kernel and open source, so that is something that I'm just used to. Everything I do gets released open source. The only reason I don't release it open source is because it's embarrassing. So sooner or later it all goes out. Now, is there a place for closed source code? Of course, the layers on top, stuff like that, we're always going to see, people doing closed apps, things like that. At your lower level of this is the technology that we all want to use and trust, I think there's less room for a closed source solution. If somebody came out with a sidechain that was all closed source, you'd probably kind of worry about what was going on.
Right. So speaking of open source versus closed source, you did a lot of work in Linux. How does the Linux community compare to the Bitcoin community?
That's actually a really, really good question. So I worked full-time as a Linux kernel developer since 97, thereabouts. So quite a long history with that. And I still, now in my spare time, maintain the module code for Linux kernel. So, I try to keep my hand in there as well. It's a really interesting dynamic because in the Linux kernel, a lot of us have been working together for a long time. We know each other really well. Those lines of communication are really, really well established. Things are less solidified and codified in some ways in the Bitcoin community. So, the players change a lot faster. And you've also got the problem that you've got Linus in the Linux community. I mean, he founded it. And for better or worse, when he says we're going this way, that's the way we go. Right? So a whole heap of discussions are like, oh, we could do this one or two ways. Eventually, somebody gets to make the call, and it's Linus. And if you don't want to do that, you can go off and do something else. But this is the way we're going, for better or worse.
So this is like the fundamental thing that Bitcoin is working against is Linus Torvalds, the point of centralization, the embodiment of the centralized institution.
Yeah, so you've got this really centralized system, but somebody's got to produce the protocol, right? Now you can argue over it, and you can fork it, and you can agree which one you're gonna deploy. But for a centralization, from a development point of view, that centralized de facto model works quite well, because what happens is if Linus goes nuts and everybody goes, no, that's crazy, we will fork the project. But he's got a track record, so you're prepared to give him the benefit of the doubt until some point at which you go, okay, maybe he's gone off the rails. That hasn't happened, and hopefully won't happen. So when you've got a project like Bitcoin where the creator drops out, it does leave a bit of a vacuum. Nobody can naturally stand up and say, hey, we're doing it this way because I started the project and I'm in charge. So it does become a little bit more complicated then to make perhaps what would be controversial decisions. And I think we're seeing some of that teething problem being worked out now in the Bitcoin community.
How does that teething problem manifest?
Well, this leads us down to the question of the block size debate. And this is one of the big areas of heat at the moment in the Bitcoin community. I'm somewhat on the fence on this debate. But it has been incredibly polarizing, and that is that there was a limit placed on the size of blocks in the protocol that, at some point is going to really cramp our growth. So that will be a hard fork. It will not be something that you can just roll out and nobody will notice. This is something that's going to require every full node to upgrade. And that's perhaps a trigger point for arguing over how should this change? Should it go to infinity immediately? Should it be scaled up? At what rate should it be scaled up? And things like that. What concerns or what will it happen to the network if we turn this limit off, which was put in place to prevent spamming in the original case? Do we no longer need that? There are a lot of questions around this, and it's really quite a contentious issue, and it has divided the 5 people who have commit access to the Bitcoin core code, which, although it's not the only implementation of a Bitcoin full node, is the one that tends to take the lead on these kind of issues. They run the Bitcoin improvement process, and they're really the ones that everyone looks to for where Bitcoin's going. And so at the moment, what we're seeing is there is no consensus, even among them, about what should happen. This is the kind of teething problem that I think you get when, a project grows up and you come across really hard problems.
It's fascinating. So, in terms of Linux, if there is this single centralization point, Linus, that is sometimes problematic, I mean, why are people waiting for him to go crazy? If he's a problem, why not just fork right now?
Oh, this is what I'm saying. If there was a problem, we would fork right now. There isn't a problem. Linus has got a really good track record of doing the right thing. So, even if you disagree with him on some small decision he makes, you might go, no, I disagree with that. That time will probably prove him right because it has in the past.
Right.
So it's worked, and the fact that it's worked means that you do give him a fair bit of credit when he says, no, we're going this way, even though as a lower developer, you might go, I really disagree with that. You'll probably go that way anyway. You may try to fork the project, but it hasn't worked out well for anyone who's done that in the past.
So at the different companies that I've worked at, there's always these different company cultures. And I imagine it's the same with open source projects where there's the culture of that comes from the founders and from the basic premises of how you do coding creates a certain atmosphere. And so maybe you could say a little more about the atmosphere, the intangible aspects of developing Bitcoin versus developing Linux.
Yeah, that's a really fair comparison, actually. There is definitely a different atmosphere. Bitcoin is a lot more like Linux was if we go back almost 20 years, perhaps. A little bit more frontier. On the other hand, it's got conservatism as required when you've got, potentially billions of dollars of money sitting around that Linux never really had to have till it was a lot older. So in some ways, this conservatism has outgrown its institutions. So institutions take a long time to come together. For example, the Linux kernel has the Kernel Summit every year, which is an invitation-only event where the core kernel developers get together face-to-face, sort stuff out. A lot of progress happens at that. There's a whole network of conferences. There's all this social infrastructure that exists for Linux that's grown up over its development. We haven't really seen that for Bitcoin because it's such a young project. And yet, there are similar kind of pressures. It's a multi-billion-dollar project. There's a lot of people really intense. It's this huge VC, magnet and stuff like this. There are a lot of pressures on it at a stage that Linux's growth was much more gentle and it had time to adapt. Whereas this is really being fast-tracked on the Bitcoin side. These things will happen, right? These things will be worked out, but we're seeing that kind of early stage, and it's going to be kind of messy.
Do you have any closing philosophical views on software development that you can share with our listeners?
Oh, wow. You should have asked me that at the beginning so I could think about it for a while. Yeah.
You can get back to me with an audio amendment if you want.
No. I think we're good. So one of the odd things that I did in my career was write election software for the government in the state I was living at that was used to count the election that year. And it was a really interesting project because I was the one who did all the coding, so there was no one else to blame. It was incredibly well specified. I mean, it was legislated exactly how this thing would be counted and everything else. So it was the perfect spec project. And there I was, I was an experienced coder with a perfectly spec project. There was a little bit of time pressure, but nothing crazy. It was optimal conditions. So of course the code was bug free. No, there was actually an out by one error in the counting. Turned out not to be important in that election, and for various reasons was really unlikely to happen. But it was an important lesson to me that even when I was being as careful as I could under optimal conditions, as a fairly experienced coder who I would, think of myself as being, probably as good as I'm going to get at that point, I still made a mistake in there. I think that's really important. It is really important to realize that you are going to make mistakes. There are going to be bugs. There are going to be CVEs that come out of the work that you do. And that is inevitable. What you can do, however, is make sure you've got as much backup as possible. And that means, the extra testing. That means other eyeballs looking at the code and all these things, because you will make mistakes and you'll make stupid mistakes. So I think that's probably the most important thing to bear in mind. That sometimes, bearing in mind that whatever you write, there will be bugs, there will be mistakes in it, and you have to embrace that. And if you're ever in a situation where it requires you to write perfect code, you're dead. You're gone. Forget it. Not going to happen. Pass that job to somebody else. Let them make that mistake.
Great. Okay, well, Rusty Russell, thank you so much for your time. Thanks for coming on Software Engineering Daily.
Thank you, Jeff. It's been fantastic. I look forward to hearing the final one.